I'm going to introduce a special guest lecturer, Fons van der Plas, who is the author of Pluto. And so if you've ever wondered who's the brains behind Pluto, it's Fons. And Fons was hoping that he could give a lecture in the class, and I thought that it would be fantastic for him to give one of the lectures. And he offered to give a lecture on how to collaborate, which I think might be one of the most useful skills that one could learn in any course at MIT. And so this is specifically how to collaborate on software. And so we're going to take a little break from the climate modeling and differential equations that we've been doing. We'll get back to that next week on Monday. But I thought that this would just be a fantastic lecture on software. So Hans, it's all yours.
All right, thanks, Alan. Hi, everyone. Welcome back to Computational Thinking. So my name is Fons, and I work on Pluto, Pluto.gel. That's the notebook system that you're looking at and that we use in the course. And so my project, so Pluto.gel, is open source, and it's available on github.com. You might have heard those two things before, open source, GitHub. Today, in this lecture, at the end of the lecture, you should be able to use GitHub yourself and understand why other people use it. And we'll actually make a contribution to a package on GitHub today during the lecture. And yeah, it's also about collaboration. So GitHub means that I put this code here, but also people can collaborate on my project. People can find the code, they can change it, and they can do what's called a pull request, which means they suggest some changes to the project itself. And then I can accept those, maybe communicate about them, or reject them. But yeah. Okay, let's talk about collaboration on software. So what's the simplest way to collaborate on any project online? You email files to each other, of course. And so this works for small projects, and it also works for small software projects. But at some point, you'll need something better. And for each task, like specific to the task, there might be a system that's best for that. If you're planning to write an online encyclopedia, then you could use a wiki system. If you're working with a group on a school essay, you could use Google Drive. But for software projects, people use GitHub. And today, kind of as a different way of introducing GitHub and Git than you might have seen before, I'll focus on this difference. Like, what's the difference between a school essay and a software project? And why do people not use Google Drive? Why don't people use Google Drive for software? It's super easy. Why are we using something more complicated? So just to get everyone on the same page, if you haven't used Google Drive before, it looks a bit like this. It's all about real-time synchronization. So right now I'm seeing the screens of two people. Actually, it's my screen. Two people working together on the same document. And you see that their changes are synchronized. One person edits, it shows up on the other person's screen. The other person edits, it comes on the first person's screen. That's super cool. Why don't we do this for software? It's not because software uses old school programs. No, software uses quite advanced programs. It's actually because there are differences between what you would use between a school essay and between a software project. So I'm going to give 3 reasons that are differences between school essays and like a software project, like a climate model hosted online, to explain why we would use something more complicated. And then that's kind of my introduction. Afterwards, I have 3 parts. Part 1 is we're going to make a contribution to a climate model. Part 2 is we're going to create our own GitHub repository, so hosting our own code online. And then part 3, if we have time, is making a code contribution to a project online. Okay, so first,
Just to ask you, are you going to recommend that we do this in real time with you, or should we sit back and watch?
Right, so that's a good question. I think it's better if I just show it kind of quickly. And if you would like to join, you can use the pause button on YouTube and just maybe pause a bit and do the steps that I explain. For example, I might say install this program, and then I'm just going to continue. I'm not going to wait. But you can use pause, and then you could actually join along. And I really encourage you today to create an account on GitHub, create a repository, and try some of the things I'm showing today. Okay, so why don't we use Google Drive? Because Google Drive is so nice. So the first reason is, in software projects, small changes can make really big differences. And if you change one file, then the entire program is affected. And as an example, Pluto is also a software project. And if you just add a single letter to the source code, it goes from looking like this to looking like this. And I can show you why. So I have the source code for Pluto right here. And don't worry about what you're seeing, but like anywhere in the source code, I type some garbage and I save. And if I now refresh Pluto, it just doesn't work. It's broken. And so what happened is, if there's a syntax error anywhere, the whole project is broken. And this is the first reason why we're not using Google Drive for software. It's because very small changes can affect the entire program. And it's all about collaboration. Like, what would happen if two people are working on the same project at the same time? To demonstrate this, say that my project has this code calculating the height from a given pressure, and it's going to, and this code is not correct, and I want to find a different code that works. And it turns out that I need to use the log function, and I'm going to find that out. Now, say that it's just like, I'm going to make this change, so changing square root to the logarithmic function, and say that it's on Google Drive, and it's synchronizing everything, like every letter that I type, just like in the video before. Then to change square root to log, I would be doing backspace, backspace, backspace to remove the square root function, and then typing log. And if you would synchronize on every keystroke, then I remove the letters RT and it's just SQ, and then it's broken. The whole program is broken. And if I would synchronize, and now also my online version of my program is broken. So the entire Pluto project will be broken because I'm trying to change one function. And you see that I do many changes. All of them are broken until eventually I get to the final one, which is not broken. So that's the first thing. We don't want to synchronize so much as Google Drive. We want to synchronize manually. So I want to say, okay, now synchronize, instead of doing it automatically all the time, because then I can make my change. And when I'm happy, I synchronize. And then you see online, so the online version of my project, it was working, and it was working afterwards. There are no broken states in between. So that's one thing. I don't want to like commit I don't want to publish every little keystroke that I make, and to kind of do it in between. But actually, when you work on software, you want even larger chunks. You don't want like to change the name of one function and to publish. You often try out one thing, see if it works, save your files. It doesn't work, you try out some other thing. Really often you make lots of changes and you don't really want to publish those until finally you tried something that works. So for example, I go from the square root function, let's try the sine function, let's try the cosine function, and finally I find the log function and it works. So I want manual control over when I put these changes online. Does this make sense, Alan? What do you think?
This makes sense.
It does, right?
I think that the issues with Git are further downstream, so I'll just wait and see if you cover them. But the concept, I think, is pretty easy to understand.
I think so too. And I think, so today I wanted to compare it to Google Drive instead of comparing it to, sending each other floppy disks with the mail. Kind of a more modern way of thinking about Git is we have Google Drive, which is instantaneous, but actually we want something else. So
I think this may be something you'll cover later, but I think one of my biggest differences with Google Drive is when I want to go back to an earlier version on the Google Drive, and this might just be a UI issue, I just click and I've got it. And whenever I want to try to go back to anything on Git, In principle, it's easy, but I find that the real world practice of it all is always a disaster.
Right.
But you
Yeah,
might
I
call that
mean,
later or not, I'm not sure. But I just thought I'd mention that I find is the big difference with Google Drive.
okay. Yeah, I will come back to this. Okay, second difference between software projects and like your school essay is that, and this is a bit more advanced, but when people have a larger software project and maybe multiple people are working on it at the same time, people found that it's really nice to have multiple branches. So we call it branches, where you take the entire code base as it is, for example, on Monday, and then you split it into two copies. And you have two people working on separate copies, for example, or one person working on two different copies, trying out two different things and seeing which of them work. And to kind of go back to the analogy of Google Drive, something that I used to do is I have my PowerPoint presentation. And then before I do something, like add a bunch of pictures, I create a copy called presentation with pictures. Then I add my pictures there, see if it works, see if I like this change. And if I don't, I just delete that file and go back to the previous version. Okay, that's great. But what if I'm working in a group? Someone else also made a copy of the file and they called it presentation with title page. They added the title page, and on the same day, I made a copy and I added pictures. Now we have two branches in parallel, basically. They added the title page, I added pictures. And traditionally on Google Drive, or just on files, it's really difficult to combine those changes. And this is something that happens all the time in software. People work on things in one branch, people work on other things in another branch, and then they want to combine them. Quite often, these changes are not even like related. So one person might have been working on the title page of their software project. Other person might have been adding pictures somewhere else. And you want to combine those changes. And Git, so GitHub makes this really easy. While in Google Drive, this whole branching idea doesn't really exist. So that's one big difference. And if you're just starting up with GitHub, you might not use this, the branching, that's fine. And I think you shouldn't maybe use it in your first day, but then try to use it later. And you will use it if you fork. So if you make a copy of someone's project, like a climate model, you make your own version of that climate model, and then you want to contribute something back. That's also a kind of forking, so branching and then merging. Okay, third reason, and I think there's like 20 more reasons, but I just picked 3 of them. One difference is that programmers love to automate things. They want to automate everything. So Git makes this really easy. And as an example, this lecture, you can read the lecture notes on computationalthinking.mit.edu. And there you'll find this notebook. But we also have we have a page on GitHub, which is right here. And this is where we put all the notebooks and the files to create that website. And so as we are programmers, we love to automate things. So every time we put a notebook here, there's all sorts of stuff happening. Let's call it GitHub magic. So a bunch of automatic things. And in our case, it's turning notebooks into websites, putting that website online. And programmers love this. They love automating things. And that's one reason why they don't use Google Drive, but GitHub.
Maybe one should mention sort of both the up and downside, probably obvious, but still worth saying, that all of this automation is fantastic when it works, and it really leads to disaster when it doesn't. And if you've encountered some of the difficulties, it's because we love automation. So, and this hasn't, so sometimes notebooks, the automation breaks and things happen.
That's right. So I actually find this aspect of software engineering, I find it quite difficult. So this Git magic is called DevOps, and someone who works in it, call her a DevOps engineer. It's quite difficult, and it's because it's so invisible or something. You're not doing things on your own computer, but it's all like happening in the GitHub cloud. So the main thing I want to say about this today is don't worry about this too much when getting started. Don't worry about it too much. Don't try to automate everything. And if you're working together on a project with someone else, just ask them for help. If they set up some kind of automation and it's not working, ask them to fix it. Don't fix it yourself.
By the way, the DevOps engineer, of course, refers to any sort of automation. It need not have anything to do with Git in particular, just so that nobody gets the wrong idea. Someone who does that is a DevOps engineer, but DevOps engineers could be lots of other things too.
All right. There's a link to the Wikipedia if you want to know more.
Oh, sure.
Yeah, one thing I did want to say is automatic testing. That's one type of automation that you will encounter. And many projects, actually most Julia package, for example, have automatic testing. I will talk more about testing later and more about automatic testing later. Okay, so those were the differences between Google Drive and GitHub, and there's lots of like more differences and more reasons why people would use GitHub. I think the main thing is you will encounter it if you keep working in academics or on software. The goal of this course is to teach you like real world problems using computers. And if you look at the real world climate model, it's hosted on GitHub or like some version of Git. So it's good if you learn this. Like personally, I found Git quite difficult, and it always jumps at your face with something new that you have never seen before. Try not to be too intimidated. I will give you a magic trick to fix every Git problem like later. But do try to learn it, and today create your first GitHub repository if you haven't done this already. All right, so I thought it would be cool if like today during the lecture, we immediately start by making a contribution to a climate model. So the one that I'll be taking as an example is Climate Margot, and we will be covering this in the course later, but it doesn't actually really matter so much today. Like,
oh, I misspoke. I said we weren't doing climate modeling today, and here you go, make a liar out of me. Cool.
Yeah, I mean, we are going to contribute to a climate model. So this climate model is a Julia package. So it was Omri Drake did a lot of work on this package, and he's actually quite good in GitHub, as you can see. Like he created a repository, he added a nice description, and he set up automation and documentation. And it's actually easier to set all of this up than you think, because there's lots of like templates. You can copy someone else's. For example, you could copy this repository and start your own climate model. So something that happens to me quite often is as I'm using a package and I'm reading the documentation and I see something that's kind of confusing, or maybe I just see a spelling mistake, or I want to add some extra explanation. So in this case, I'm reading the documentation of Climate Margot online. And it could also be that you're reading the documentation inside Julia, so inside Pluto, and these are the same. And I'm just, gonna skip a bit, but let's say that we don't really like this way of describing the T function, and we think that we should add something. Now, normally to make a contribution to an open source project, it's a whole process that I will try to explain today, which means forking and then creating a pull request. But it's actually quite easy to do it just in your browser. The only thing you need is a GitHub account and a friendly profile picture so that they know that you're a nice person. So the first thing we need to do is go from the documentation to the source code defining this documentation. Sometimes you're lucky and there's a button right there in the documentation that you can click that will jump you straight to the documentation. This doesn't always work. That button isn't always there, I mean.
So Fons, just to be clear, this is specifically for the software, right? I mean, like if you looked at the words, for example, that you're not changing at the moment, right? It's just the function that the method you're editing right now, say.
Yeah, that's right. So this is what's called a doc string. So let me just show the code. So here's the definition of the function t, and then right above it is a doc string.
Because
And
other
so
times
that's,
you might want to, you don't like the explanation and you feel like you can improve that, but that's a different thing.
yeah,
Yeah.
let's actually do that one because that illustrates my point that there isn't always the blue button. So let's say that we don't like this sentence. Now there's a trick, which is you take the sentence, oops, you take the sentence that you want to change, like this one, and I'm going to copy it, and then I go to the source code of the package, and I search for that sentence. And that will jump me straight to the file in the documentation where this sentence is defined. And now I don't need to completely understand like what this doc source, what this structure is. I know the documentation is right there. And if I just want to fix something small, add something small, you can often do that without needing to understand everything.
In fact, you could just hit
So the
that
first,
you could hit the little pencil key, right? Or whatever that is.
that's right. And that's what we're going to do. But the first thing is, and this is kind of silly, and I wish GitHub would be better at this. I can't click it right now because it's saying you must be on a branch to make or propose changes to this file. This didn't make sense to me the first time I saw it, but it means that on the top left, you need to choose a branch. You just choose the default branch, which is always called main or master. Now you're on a branch, and now GitHub is happy. So I click edit this file. And so in the background, it will create a fork of this repository. In my case, it did not make a fork because I'm actually one of the authors, or I didn't do much, but according to GitHub, I'm one of the authors of this package. So it didn't make a fork, but the process looks exactly the same. It will create a fork, and then you'll end up in this screen. Now let's say that we want to add hi from Alan, Fonzie, and Philip. And we can preview our changes. Am I happy? So I write a little description, add important information, and I choose this option, create a new branch for this commit and start a pull request. So I'll do this. And I will write some extra information here, but just because this is a demo, I'm just going to create this pull request.
Does Henri know that you're doing this? I mean, he's going to get a message, right?
Yeah, I let him know yesterday that he shouldn't click merge on my next pull request.
Good.
Okay, so actually I can edit this later and add a description. This is a great addition. Please merge. Okay, so this is a pull request. I just created a pull request. And if I go to the project and then click on pull request, you will see my pull request right there. And now it's up to Henri to merge it, which means that my change will become part of the project. Right, so there's one thing. So sometimes that's it. That's the end of your pull request. But there is a process after a pull request because quite often it doesn't get merged straight away. But for example, Henri will add some feedback. He might say, I would like you to also make this change to another documentation, or there's always some context that they understand that you don't, or the other way around. And they will
feeling that people actually will even respond at all. I mean, that
yeah.
What's your own
You said this last time we talked. I think in my experience, I do get a response. And it's because the packages that I happen to do contributions to are quite active. There are people still working on them. But it can also happen that you happen upon a package that doesn't have a lot of activity anymore. The people are done. They moved on to something else. In that case, you might not get a response. And my tip would be send them an email or talk with people who also work on the same package.
Right. So you kind of can't just sit back and hope, right? You got to somehow take a more active role if you're determined.
Yeah, I think from the perspective of a package author, it's always quite exciting when someone creates a pull request and you're like, yeah, let's see what this is. People do like it when you create a pull request, and I think more often than not you'll get a response. Okay, so something that can happen is they will ask you to make another change. They're not quite happy with what you did yet. You need to make a change. And this is possible because a pull request is not static. It's not like one pull request that you made right now, you want this change. It's a pull request goes from one branch to another branch, and you can make changes after the pull request. So if someone asks you to change something, you can do exactly that. And you see that so Fonts wants to merge one commit from into master from this branch, which GitHub created for me. And if I want to make more changes, then I go to this branch, and I'll show more about this later. And I can just keep editing files. So the file that I edited 3 minutes ago was this one, and I can make another edit. Like, for example, I forgot to say David. There we go. And now I just commit that to the branch. And if I go to my pull request, you see that there is now a timeline going on. And it says, first, I added this important information, and then I added the name David. And I can click on these two. And you see, in this case, I changed this line to be this line. This is always how Git works. It looks at the difference between lines of code. So it says that this line of code changed into this line of code.
So is there any point in mentioning out loud that a branch is a sequence of commits, and so what's changed is from one commit to the next commit?
That's right. So a commit, and there's a bit of terminology here, right? But a commit is a set of changes to files. And essentially a GitHub repository is, it starts out from an empty folder, so nothing, and you keep adding changes on top of each other. And those changes can branch out. So you can start from one point and then do a bunch of changes in one branch and then do it in another branch. What's actually funny is in any GitHub repository, you can click on this thing called Insights, which sounds very cool. And then you click on Network. And here you'll see this, maybe a picture that you've seen before, like a graph view of your repository. So this is a timeline going from the past to the future. And you see that commits, so changes are dots. For example, here, it's kind of hard to see, but it branched off and it made these two commits. And now if you would merge this, I'm not going to do it because the changes I made are kind of silly, then you would see it go back into the black line, which is master, which is merging. So then those changes become part of the main branch again. And this is kind of cool. I think you should go to a repository that you like Julia, and look at their network. And then you'll see all this magic that they're doing with branches and merging and, and all that stuff. Also nice, create your own GitHub repository and play around with this, and then look at your insights and the network and see what those changes are doing in the graph. I want to show one more pull request, just something that I found randomly when preparing this lecture on Julia. Again, it's not really important what's going on here. I'm also not quite sure, but I just want to show what a pull request looks like in the wild, right? So this person proposed some changes to files. So you see that in this case, there's multiple files that they wanted to change. So that's the first commit. And then someone left a review. So a repository like Julia has lots of people reviewing changes. They don't just put anything in there. And then for the review, it's always quite technical. And they might leave a review specifically about this one change. say like this change could be simplified and that sort of stuff. And eventually you might get an approvals from someone, and you see that they added new commits after getting that feedback. So they changed their pull request. Then eventually they're happy, and then someone merged the commit. All right. So I think what would be really nice is if right now we create a GitHub repository and put it on our own computer and kind of use it like Google Drive. And you also see the differences between Google Drive and GitHub. Okay, so I'm going to go to github.com, and I already created an account. And then when I'm logged in, on the top right, there will be a button to create a new repository. You can start with a template, which can be useful if you're creating a Julia package, for example. And I'm going to call it hello MIT. You can make it public or private, and I will add a README file. And you'll see what that is later. Okay, so now I have a public repository, and this is a link I can send to anyone, and it's a folder that anyone can see. And first, just on the website, we're going to make some changes. So I created this README file, and I can always edit with a little pencil and say, hi, everyone. And I will commit. Commit means I'm happy with these changes. And then I push them. So on the website, this is all quite easy. Okay, next, I want to get this on my own computer. And for this, there's a couple of steps. So first, create a GitHub account. Next, to synchronize files with your computer, I highly recommend downloading GitHub Desktop. It's like a graphical program to do all of this GitHub stuff. It's only for Windows and Mac. The Linux users can use Git Kraken, which is a bit more difficult, but it works on Linux. And then you need a code editor. I really recommend using VS Code. That's a free open source, beginner-friendly programming environment. And you might be thinking, I don't want to install new things. It's more difficult, learning even more stuff. But really, so like I was teaching children to program at school, and I was watching them use Notepad or gedit, and it's just so much more difficult if you use an editor that doesn't understand the code you're writing. It may not seem like it, but use an editor that's kind of smart, and actually, it will help you.
Fonz, I'm not sure this is completely the truth. For example,
it's my truth.
Well, I mean, there's a certain amount of work, for example, to set up. Let's say you're writing Julia code, right? There's extra steps that are not intuitive. Like what is it? Control P something or whatever. Like nobody ever remembers these things. There's a lot of there are a few things, a few gotchas to VS Code.
Yeah, I mean it's not entirely just simpler, but I do think it will help you in ways that you don't know
I
yet.
agree with Fonz that it's worth it. I'm not completely convinced that you can just plug and play.
Okay. No, I mean, I guess that's a good point. Okay, so you get these programs. I already installed them, and then if I have my this one, hello MIT. If I have it, I click the big green button, and then I say open with GitHub Desktop. And so now it's going to ask me, so this is the URL, so where my repository is online, and it's going to ask me for a path, so where it's going to be on my computer. And it's going to synchronize this online repository with this folder. And you also say that this is the remote, so what's online, and this is the local, what's on my computer. So I'm going to click clone, which is a secret word for saying download. And so now it's cloned, as they say, and I can click show in Finder, or if you're on Windows, it will show it in Explorer, which is a cool name. And you see that I have a folder on my computer now, which is in my documents, which has this README file, and I can open it with VS Code, but actually I'm going to open the entire folder with VS Code. And there's also a button for this. Let me just minimize. So you don't see much, but on the left here, you see there's the README file saying, hi, everyone. And then, hi, everyone, and Philip. So let's make this change. And I'm going to save this. And now, no, actually, first, if I go to the website and I refresh, right, it's not Google Drive. It didn't synchronize. I added something, but it's not on the website yet. And that's because these changes, the synchronization is always manual. So I need to do something before it gets online. And you see that if I go to GitHub desktop, the view now changed because there's a changed file. And on the left, you're going to see all your changed files. Right now, it's only one. It's saying this line 3, got replaced by this line. And that's always how Git works. It looks at differences between lines and tries to be smart about this.
And I guess the yellow square means the color coding is modified as opposed to deleted or added, or I guess there's some other color codes.
That's right. So if I hover with my mouse, it's saying modified. And it's always the GitHub colors, like green is added, yellow is modified, red is deleted. Okay, so I select which changes I want. In this case, there's only one, and I say update README. So let's make this the description of my change. It's quite nice if you write a good description for your change, because then later it will be easy to look at your history. I did commit, which is the blue button. Let's check the website. It's still not there because committing is not enough. It's 2 steps with GitHub. They separated this for a reason that you will eventually find out. It took me 2 years to figure out, but commit and push are separate. So I click commit first, and then on the top right, I click push. And now push means upload. It's going to get the changes that were on my computer, make sure that they're also happening online.
Can you explain the difference between push and fetch, which just showed, they just gave you the option to fetch.
So I just click push, and now this button got replaced by fetch. Fetch means, so the remote, the local, they both have a collection of changes. And fetch means make your computer, so your local, aware of what's happening online. The best practice is to click this button all the time. And then you're always aware that maybe something changed online. That's actually what I'll show right now. So you see my commit showed up. I can look at all the commits to this repository. I just added Philip. I can click there. You see the change. Let's go back. Okay, let's add a new file. So create a new file and call it friends.txt. I'm going to write names of my 2 dogs. And I'm gonna create this file. And so if I look at my folder, it's not there because again, it's not synchronizing automatically. It's Git, it's synchronizing manually. And now I need to click fetch. And this is why it's important to click fetch. You always want to pull changes from what's called origin, which is another word for saying the source, the remote. So
I tend to associate the word origin with the thing that's on the web. I don't know if that's the exact right meaning, but it seems to be usually true.
To be honest, I don't know what it means, but that's the same association that I have. Yeah.
Yeah. So I think if in practice, if you think of it as the state of the universe on the web, that's kind of not a bad way to think.
I think, you know, as people can tell from me and Alan, we've been using Git for a while and we still don't know all of this stuff.
I'll say something stronger. I spent years thinking that all these people around me are really good at Git. And like, I'm the one who just doesn't know all of these fancy things. But then when I ask the fancy people like how to do simple things, they don't know how either. And that's when I learned the real truth about Git.
That's right. And I think people should keep this in mind. It seems super intimidating, and sometimes Git will give you these error messages or whatever. people around you also don't really know. Just try to keep it simple. And if things break, I'll give you a strategy to fix it.
I think I've often thought that the first thing that you should tell people, maybe you will before the end of this lecture, is if you really mess things up completely on your own machine and you just want to get Origin, the thing that's on the web, and get rid of everything else on your machine, and just not have it give you any annoyance, what do you do? But maybe you'll get to that later.
Yeah, that's exactly the
that
golden
the
tip
most
that I
useful
wanted to
lesson.
say.
Right. Okay, but go ahead. Go do what you're going to do.
Okay, so let's say that I make 2 more changes, like I add exclamation points here, and everyone and Philip also more exclamation points. Now go back to GitHub. You see that there's 2 changes, 2 files changed at the same time. And this happens often in code that you're editing 2 files and they need to match. Like you change the function name in one file and then you're using that new function name in another file. So you always need both files to be at the same versions. So that's why GitHub has these checkboxes. I can say, I'm going to make a commit, and I can say which files do I want to put together into a single commit. So now both are checked, and I'm going to say more exclamation points. Make this a commit, and now I need to push.
Oh, so you just did 2 files at once. I sometimes have trouble with that. Interesting.
Yeah, Alan told me that he sometimes has trouble with this.
I'll have to replace it. We'll see what's going on. But that's just purely GitHub desktop. It's not GitHub.
And so you see this. So you see that this one commit has both files changed at the same time. Okay, let's talk about. Okay, so there's some vocabulary here. If you would like to look at the website, let's talk about Git trouble. Git gets in trouble sometimes, especially if you're working together with multiple people and there's a lot of work happening on the same day, you will get into trouble.
Yeah, and this will be sooner, not later.
This will be sooner, not later. And that's because unlike Google Drive, synchronization can require manual intervention with Git. Google Drive will always synchronize, like no matter what you do, even if 2 people are editing at the same time, it will figure out a way to delete someone's changes. But Git is very conservative in this way. It will never delete someone's changes. It considers them as holy. It will never delete changes. And you will have to go through a lot of trouble to convince Git that no, these changes don't matter so much. It's okay. You can delete it. And as a quick example, I'm going to create what's called a merge conflict, something that happens to me often. So online, I'm going to pretend that I'm someone else working together on this project. And maybe I delete these 2 exclamation points. I'm going to commit this to the main branch. And now it's online. And then on my computer, I still have the old version. I didn't synchronize. And I was working on this code and I just changed this name to Floopy instead of Floop. And I save. And now, right, so I can make my commit and I need to pull. If I do this, if I click, pulling is always nice, getting the latest changes. It's going to say error, blah, 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 blah. It's talking to me about stash. Now you can look up stash and learn about stash if you like, but I'll tell you about my strategy for dealing with stuff like this. Which is to just remove your clone and start over. So, I mean, this is not a super dramatic problem and it will be easy to fix, but let's just pretend that we're completely stuck. We don't know what to do. We want to give up GitHub altogether. Don't. So the first step is find out which files have changed. Are they important? So in this case, I see, okay, I added this. Actually, it's not super important. So
why can't you in GitHub Desktop just switch to Origin Master and just keep working from there? Like there's that drop down under current branch. It's not there.
I'm not sure, actually. I think it's because I am on origin master. I'm sorry, I don't know.
You're on main according to what we can read on.
I wonder
Right,
if there's
so
a setting that you can change somewhere.
Sorry, David?
That. I wonder if there's a setting that you can change somewhere
That would let you do that.
that will let you see that.
So that would mean that you wouldn't have to do what you're about to show us. But let's go ahead and see your way. Let's do it the Fonz way. Which, by the way, I'm about to say that it would feel scary to do it because you feel like you're about to wipe out all your work and maybe everybody else's too. And so you
right,
might.
So Git never wants to wipe out your work, and that's why this pool doesn't work. It doesn't want to delete your changes.
Right.
So
but
let's say that.
But go ahead, do it your way. Yeah.
So one thing could be I don't care about these changes. Then I could do right click and discard, and then it's just going to send it back to the last version, and then it's clean, and then I can do pull. This works in a lot of cases. Let's say that I don't want to discard. I'm going to do something else, which is take the file that I like. I'm going to copy it, and I will put it on my desktop. And now I can discard all changes. And to be more dramatic, you can even remove the clone altogether. So remove the files and start over.
Can GitHub Desktop do that? Can you just remove it right there?
Yeah, so I can do repository remove.
Oh, look at that.
And then I say also move it to trash. It's okay. And now
this is the part that seems like it might be scary, but it's really no big deal.
And that's because I copied the file before, right? Now I just clone it again. So do the same steps before, green button, get the desktop, put it in the same place. Now it's there, and you see it already took that latest commit. So where I removed exclamation points. And now I can take the file that I liked, copy it, go back to, go back to repository, and I just replace the file. So I remove it, put it back. And now you see that this, I added the loopy, but also the exclamation points are there. And now this is the point where you might want to look at these changes yourself, maybe make edits to keep both changes.
Can I kind of echo what you just said, maybe with my own words, just because of the way I would have thought about it until I understood how it really worked? It might have seemed that by removing the file completely and then downloading the web version, the one that was, in GitHub on the web, that when you brought the file back, you made not just the one change, but you might have made a change on every line. After all, the file wasn't there, and then suddenly it was there again. But of course, that's not how it works. What it just does is a diff of the file as at the moment of commit with what it had in the previous commit, right? That's all it has. And anything in between that you do, delete it, put 1,000 lines in, delete it, right? None of that matters. It's just the diff between the previous commit and the current commit.
Diff meaning the differences.
Right. The
set of the collection of differences between the files.
You have this friends.txt on the web. You have this friends.txt as it exists at this very moment in time. And it's just going to do a pure comparison. And you've got that extra IE exclamation point. That's the only real difference. And that's all that's all you're going to see at this point.
So actually, no, it's saying that I'm also adding the exclamation points, because before I did this, Fonzie's trick of doing the hard reset, I had the exclamation points, but the online version didn't. So this is really the hard reset. And in this example, it looks dramatic, but I can just add it and say, did I want these exclamation points, yes or no? I could now use a code editor to manually fix this. Now, what I just explained was not how you will do it a year from now. A year from now, you will do merge conflict resolution, where you use VS Code or another editor like this to choose which of the changes do you want. It's like, did I want this version of the old file and I want this part of the new file? But until then, I think it's good to know that you're not completely stuck. You can always just do a bit of tricks like this and manually look at your changes and see what's up. Okay. Yeah, this file just showed up. That's something that macOS does, is it creates a little .ds store file. Happens sometimes. Sometimes you just get file changes that you don't want. I do right-click, discard, and then it's okay. Okay, I think.
So I was going to say that you don't need to do. I mean, the sort of more advanced way would not be to move the file out of the way and all of that. It would be to create a new branch. Is that what you said?
Yeah. So in this case, you could either use the stash feature, like GitHub Desktop suggested, and then with VS Code, I could compare the difference between my stash and the latest version, and then choose what I want. Or you could have created a branch like David suggested. So before pulling, I just quickly create a new branch, put my changes there, like as a little house, then pull. And then, for example, I can merge using a pull request, which is quite easy to do. Okay, so there's one part about how to fork and contribute code to a project. So what I showed before was how to contribute just a small documentation change. I'm not going to show it today because of the time, but it's just a combination of what of the past two things I showed. So doing a fork and making contribution using a pull request. But if you're contributing code, then you want to get that code in your computer, edit it on your computer, try it out on your computer. And when you're happy with the result, you put it online. One thing that I did want to talk about, I mentioned it before, is testing. And this is something that you will see again, and it's super useful if you learn how to use this well. People often write tests for their own code. People write tests for themselves. And as part of the code base, people have a folder called test containing scripts that will import their own code base and then run some basic checks on it. Kind of as a simple example, I did it all in this one notebook. So say that I'm creating a function that doubles a number, I can add some tests. Like I want to check that if I apply it to 3, then I really get 6. And say that I wrote this test, it's going to be test failure. And that will show up. Like if I create a pull request, it will automatically tell me one of the tests just failed. Or if I run the test on my own computer, like I did here, it will tell me. So one reason to do this is after you fix something, like fix a bug, like used to be a bug that the double of 2 returns 40 and it should be 4. And after you fix it, you would add a test to kind of pin down this behavior. You never want this to break again, because once you've written a test in your program, that test will stay around. So later, when you like months later, when you forgot about this and you're doing something else, you can still run that old test and make sure that it works. And a little fun side note is test-driven design. Some people like to first write the test and then write the implementation. So like I might start out just by writing double of x and see like, oh, it already passes this test. I just need to make it pass this test. So maybe times 2 and then that works. And it can be rewarding and effective to first write your test and then just keep tweaking your code until all of your tests work. And if you've been following this course, then you're already familiar with this concept because the homeworks were all test-driven design. So in the homeworks, we already wrote the tests for you and you write the function. And I hope you found that by already having the test there, it's clear what you need to do and it's more satisfying when it works. And then there are ways to run the test like on your own computer or again using GitHub Magic. All right, that was it. 2 more tips. Contributing to open source does not only mean contributing code. I have a little link here. There, you can also contribute by making more examples, by finding issues and sending what's called a minimal working example. So if you find a problem, try to write a little script demonstrating the problem and send it to to the creators of your package. And second, today go out and create your first GitHub repository. A lot of people, including me, have a couple of test repositories on GitHub where we just do stuff like create branches. If I'm working on something and I wonder like, would it work if I have one branch doing a pull request into another branch? I always try it on my test repository. Yeah, that's it. I think GitHub can be difficult at the start, but I know people who write their shopping lists on GitHub. It can be a great tool, especially for publishing your work and putting it online forever.
And the reason to have your shopping list is so you can go back and see what you bought 6 months ago?
Yeah, you know, if you want to contribute on the shopping list, you can do pull requests and kind of approve or disapprove.
I see if you're shopping for a family or for a group or something.
Right.
I see.
All right. Thanks again. Thanks, Alan.
Hans.
Thanks, everyone, for listening.
We'll end the live broadcast, and possibly if you could stick around for a little bit and see if any of the students or otherwise have questions for you, it'd be great.
All right. Thanks.